Okie doke. Hello, Louvre. We've been very much on topic this whole time. Okay, so to this. Everybody, what I want you to do with this is, first thing we're going to do is that. Tear it apart. We're going to want them kind of lined up next to each other as we go. You can go ahead and write, this is 2.4 on top of this. Lesson 2.4, and today is 10/28. Okay, this is, anybody a Vikings fan in here? Okay, are you a football fan?
Don't watch NFL like college.
Got it. Anybody NFL fan? Okay, I picked the wrong thing to focus on. Anyway, this is real data. The Vikings, this is their first 6 games. As you can see, they were pretty much killing it until 10/21, where they barely lost to the Lions. Okay, so today what we're going to do is we're going to figure out how to do population standard deviation and understand it. So I need you to grab a calculator if you don't already have one. Okay. So a population mean, do you remember what Greek letter that's denoted by? Huh? Do you remember what Greek letter a population mean is denoted by?
The X bar.
Oh, close. That's a sample mean.
Oh.
It's like a weird Q looking thing.
It's not a weird Q looking thing.
No, you.
The mu.
It's, yeah, that's called mu. It looks like a lowercase u with a tail out front. Some people just draw an M, but it's supposed to be like a U with a tail out front. Okay, how do you find out a population mean? Just like normal, how do you do it? Divide, all right, so add them all up, which is sigma, right? So adding them all up and dividing by how many you have. So this means add your data points. And this means divide by the number of data points. Okay, so all we're going to care about today is our scores, not the opponent's scores. So I want you to take a look up here. Look at our scores for these 6. By our scores, I mean the Vikings. Okay, so look at the Viking scores here. What would you guess is a reasonable average? Doesn't have to be exact, just guess. 25. Upper 20s, 28 maybe? That seems reasonable. What's unreasonable? Stupid answers.
Oh,
100. Yeah, something way bigger than even the biggest score. That's true. What's stupider than 100?
-50.
-50, -5. Yes. Okay, we're all getting it? So everybody in your calculator right now, 28 plus 23 plus 34 plus 31 plus 23 plus 29. Wow. That worked out pretty exact. Did you guys get exactly 28? Okay. All right, so our mu for this population set is 28, which I did not know until just now. I did not set this up. Also, today's the 28th. What? Okay. A deviation is how far each data point, I'm going to write it down, how far each data point deviates from the mean. So deviation is how far each data point deviates from the mean. Some of them will be below the mean, which means they'll be negative, and some will be above the mean, which means they'll be positive. The formula for this is x minus mu. For example, let's look at the Packers game. Okay, what was our score on the Packers game? 31, so I'm going to take 31 minus 28, which is? Three. So the deviation for the Packers game is positive 3. By the way, the fact that it was exactly 28 is pretty rare. Usually you're going to get like 28.1 or something like that, where it'll be like a decimal. Just happened to work out this time. Okay. Population standard deviation is how far the data points deviate from the mean on average. It is how consistent the data is. Okay, let's say that our team, our average was 28, and we always scored 28. Doesn't matter what game we play, who we're playing, we're always scoring 28. At the end of the game, it's 28. Even if they score more than us, we're still scoring 28. They score less than us, great, we scored 28. Okay, we're always 28. How consistent are we? Really consistent, right? We're right across the board. Okay, a consistency would be 0 there, because we are always exactly, we never deviate. Our deviation is 0. We never deviate. We're never off the average. We're always right on 0. That makes sense to you guys? Now, if you've got a low standard deviation like 0, does that mean that you're a good team? Not necessarily. Why not, Tristan?
Because you could lose.
You could lose. What if there was a team out there of professional Laura Nussbaums, okay, and it was a whole team of just clones of me, and I was going up against actual professional football players. I don't even know how to play football, okay? All right, so every game is going to be a blowout, and my team's getting 0 points, and that's not just like a dig on me. Like, I don't know how to play football, like, impossible, okay? So I go out there, me and my clones, we go out there and we're just 0 in every single game. Are we consistent? Yeah, we're really good at getting 0 points. Like, we're really good at it. We're super consistent. Our standard deviation is 0, killing it, doesn't kill it. All that means is that you're consistent. So the mean is what you want. What you want, I guess if you play football, is you would want a high mean, because you want to get a lot of points, right? And then you would want a low consistency with a high mean, which means that not only do you get a lot of high points, but you usually do. Because you got some games, you know those football teams that are all over the place, or any team that's all over the place, where one game it's like 7 points, and the next game it's like 54, and then it's like 8 points. Like it's just like wildly different depending on who they're playing. The formula we're not going to write out until we figured it out together, and that's what I did. Okay, so we're going to do this in 3 different ways. One way is going to be in words. One way is gonna be in symbols.